Hey guys, thanks for tuning into this video. Today we're looking at a Northrock that we're doing a conversion on with a Bafang BBS02 mid-drive 750 watt motor and a 48 volt 30 amp hour triangle battery. This one has the DPC 18 color display, which is a really nice display. Shows you your speed, you get sport mode, eco mode, shows you your watts, battery percentage. So first thing we're going to do is we're going to pop off the existing crank. So in order to do this, we need to pull off the crank arms. So this is the chainring side. We have our crank puller tool, which is usually included in the kit, and pull that in. And I use an impact gun, but you can also just use a wrench, and that will pull the crank arm off of the crank. So once that's off, then we can move on over to the other side. Same thing. First, the 8mm Allen bolt that is inside, we'll pop that off, and then we'll throw in that crank puller tool, again threaded in. There's a thread inside the crank arm there, so once threaded in, get it locked in, and then again we'll use that middle bolt, drive it in, and that's going to press on the actual crank itself, and that crank arm will pop off. And obviously these brand new bikes, this one in particular is brand new, makes it a lot easier for these to pop off. Sometimes it can be a bit of a wrestling match. Now we're going to take off the pedals. So this is the left pedal, and you can see a 6mm Allen is able to take it off. I'm turning it counterclockwise here, and that pedal pops off. Do the same on the other side. Again, we got a 6mm Allen on the inside, which makes it nice. You can also use a spanner wrench. I believe it's either a 14 or a 15. So this is the other side, and it's the opposite rotation. So with my Allen, we're going clockwise, and then that pedal is going to pop off. Now the next tool that you need is a bottom bracket cup removal tool. These are usually not included in the kit. These are about a $10 buy on Amazon. So we're going to start with the left side. The left side needs to be, it needs to go counterclockwise in order to loosen it off. So, and again, on the other side, it is the opposite. So cranks as well as pedals have, one of them is reverse thread. So the left is standard, lefty-loosey, and then what I like to say is on the right side, right is reverse. So now we're on the right side, this is the drive side. Again, put that cup removal tool, and we're going to go clockwise. And once this is out, this will actually remove the entire bottom back bracket cartridge. And these are a 100mm bottom bracket cartridge, so the 100mm mid-drive kit is the kit that is needed for this particular conversion. These are a sealed cartridge crank, and there we go, that's off. So now our crank is off. We got our parts that need to come off, and let's take a look at what is inside the box. We got our chainring guard, chain ring, we've got our fastening hardware for the motor. Then we've got our little manual, our spanner wrench for the Bafang specific nuts that hold on the motor. Crank arms come with the kit. Those are 250 watt stickers. We're using these magnetic hydraulic sensors in this case. That way we can retain our nice levers. That's a speed sensor. We have the harness there. There's the front headlight included, the thumb throttle included, and that is the motor. So we've got 4 connections there. Sped through them a little quickly, but we'll go over those again. So first thing we want to do is pop the motor in this case, because the battery cable is so long, I like to cut it down and also switch over the connector, because the standard bullet connector is not the best. So we're going to eyeball it to where we think is a good length. Make note of that, and then we'll pop out the motor, and then we'll go to the bench and we'll chop that cable. You want to chop one wire at a time. or else you'll have a little arc from the bit of capacitive charge left in the controller. So you can see I'm kind of picking away at the insulation and then cutting one wire at a time. That way we're not going to get that arc. Then stripping that insulation back. And in our case, we're going to be using XT60 connectors, which are one of my favorite connectors. They're good for 60 amps, which is more than enough. This particular controller only draws a max of about 24, 25 amps. So we'll solder that in. And obviously the battery side will have to be the same. So depending on what battery you're using, a few good connections are XT60, XT90, Anderson. The bullets I'm not the biggest fan of the bullets. So there we go. We got our XT60 all done. It's nice and waterproof, using a 3-to-1 heat shrink that has an adhesive on the inside. Okay, and now we will slide our motor back into place. So it goes in nice and easy. There's no cables running under on this frame, which is really nice. Makes for an easy installation. Now we're gonna put on these hose clamps. So these are stainless steel hose clamps, and these are just an added structural support because often these motors can come loose. So what I like to do is use some heat shrink over the hose clamp so that it doesn't scratch up the frame. So first thing that we'll do is we'll kind of just see how much heat shrink that we need to put on, mark it with a Sharpie, and we'll do the same thing for the motor. I'm buying these hose clamps from Princess Auto. I'll put a link in the description. The big one is a 3.5 to 5.5 inch, and the small one is, I believe, a 1 inch to 1.5 inch, but I will verify that. So again, we're going to kind of just see how much of that clamp gets used, and then we will put a mark in place with our Sharpie, and then we'll feed heat shrink all the way up until that point on the hose clamp, and then we will interlock those hose clamps together, and then that will kind of keep the motor secured to the frame. Slide in our heat shrink, and then heat it up to get it to shrink. I'm using a torch. You can use a heat gun, lighter. My torch is on its last legs. The igniter's not working too well. And we'll do the other one. Okay, so once those are all shrinked up, we will put them in place. So it doesn't really matter which one first. In this case, I'm installing the motor clamp first, and then followed by the frame clamp. And again, this is an optional thing. You don't have to do this. There are other methods to more securely keep the motor in place. Like a lot of vendors sell almost like a torque arm that connects at the mounting point on the bottom bracket and goes back to the swing arm and uses the swing arm as a brace. So we're putting the chain ring on. This is probably better done on the bench. That way the chain ring can go on, and then the cover guard can be installed at the same time. So this cover guard has 5 small Phillips screws that just thread into the plastic. So you can see right there, that's where they threaded, and that's where I screwed the Phillips screws into. So we got all 5 of those on. A little bit easier done on the bench, but now it's in place. So this is the main way that the Bafang motor secures to the frame. It basically just tightens very, very tight, and then it has this little bracket that bolts into the motor itself and then bolts onto the bottom bracket. First thing that we want to do is test if these are appropriate. So sometimes you'll need spacers, because when you put that bracket on, you want to make sure that it lines up flush, and in this case it did. It was perfect. So we can just tighten it up, make sure to put some Loctite. That will keep it from coming loose over time. These motors do tend to come loose if you don't use Loctite. And now we're going to start feeding the wiring. So we've got our 4 wires there. We've got the yellow one's the shift sensor, we've got our battery connector, and then the other 2 are the speed sensor, which has the big white arrow, and the harness which goes to our handlebar, the 1 to 4 harness, sometimes called 1T4. And we're just gonna strap these in place. A lot of these zip ties end up being temporary, but at the bottom little two there are for the light. So we'll also hook our light in. And the light has 2 black wires, but one of the wires has a white stripe on it, and that is the positive. So it's a little tricky to tell at first, but the light itself has a red wire and a black wire, or a red wire and a blue wire. Red is positive, and that connects to the black with the white stripe. So now that we've got those all in place, we'll just secure them with our zip tie. Kit comes with some zip ties, but always good to have extras, and always good to have long ones. And then I like to put a couple of zip ties down below as well, just to hold all of the wires together, because sometimes one wire will get snagged and then it can pull right out of the controller and damage the controller, which sucks. So here is the speed sensor, and this is how it goes on to the frame. So there's a little black screw which you screw in place, and that's going to go on the speed sensor, and then the magnet is going to go on the spoke. So you tighten the spoke down, and then we mount the speed sensor, a couple zip ties, and it's good to go. You want that you want the speed sensor and the magnet to be about 3 to 5 millimeters apart, so not very far away from each other, and you'll want to see when it's spinning that red light is flashing. So here we're going to be doing our cable management. So we want to take our harness and our light, and we want to put some straps along the seat tube and the top tube, and we're just going to get that in place so that it'll be a little bit easier for us to manage our cabling. Luckily this cable, this 1T4 harness, is approximately the right length when it goes up and across the top tube. And we'll take a look at adding our shift sensor. So we cut the tip of the cable, loosen the shift cable, unfeed it, and we feed it through the sensor, and then we're going to feed that cable back in and put our shift cable back in place, tighten it up. We want it to be just slightly taut, and then we're going to strap our shift sensor in place. We'll cut that zip tie, and then we will plug that into the motor. And to test it, we want to be on the smallest cog, and we want to see if it is going to shift. So once we move it, we want to press our shifter up once, and we want to see if it moves. So you can see it's good. So guys, I know I didn't touch upon this, but I just wanted to touch briefly upon this. The hydraulic brake sensor that's being used here, it is a magnet that is on the brake lever, and then it is a sensor that's on the perch. And so when that brake lever gets pulled in, the magnet gets pulled further away, and that allows the controller to know that the brake is being applied. Got our display in the middle, our thumb throttle is on the right side, and same thing on the left side here. We got that magnetic hydraulic brake sensor. Now it's hydraulic because normally this is used for hydraulic brakes, but they can also be used for cable brakes. And the brake levers that come on these bikes from the factory are quite nice. They've got a rubber textured grip right on the lever there, which makes it a lot nicer than the stock brake levers that come with the Bafang mid-motor kits. So that's why we opted to go for those. And that is pretty much how our handlebar is set up on this bike. Okay, so now let's take a look at our bike with the motor installed, with all of our handlebar accessories installed, shift sensor. So this is basically ready to go other than the battery. So the next stage is going to be the battery, how we put that all together, all the way from the design part and up. So let's take a look at that. We're doing a 48 volt, 30 amp hour battery using 2170 cells, 5000 milliamp hours of cell. Okay, let's do a quick look at designing a triangle. So our triangle is going to be using 2170 cells, but we want a small gap because this is going to be producing cell holders. So we have a gap here of 21.8 versus the normal diameter of about 21.4 millimeters, and we're going to do a spacing of 22.8, so 1 millimeter gap, because I have a 0.5 millimeter nozzle on my printer. So 0.5, and we're going to be 2 walls. Separating them is 1 millimeter. If you have a 0.4 millimeter nozzle, you could do 0.8 as your gap, so 22.6 here. Both will work fine. So we're going to make these equal, and we're going to do a construction line right here, so that when we add another cell to this, it's going to be spaced out the same. So once we have this, we're going to do a pattern. We're going to make the pattern repeat 20 times, and up we're going to have it repeat also, let's say 20 times. And that is what it will look like. We're going to drag this so that it touches that line, and we're going to drag this circle so that it also touches that point. And from here we have a huge pattern, and we can extrude this so that it looks like a cell. We can extrude it 70 millimeters. So obviously we're going to cut it right down, but this just allows us to have a huge chunk to select from. And from there we're going to narrow it down to our sizing and also our amount of cells. Now that we have an idea in mind, so we're going to need 78 cells. So 13S, 6P, 13 times 6, and this is all 78 cells. So we're going to highlight all of these, and then we're going to reduce the offset of the circle for our cell holders. That's what we're making. We'll draw an outline, and then we'll fill in the gaps of that outline. We want all of these to be tangent. So once we add all of these arcs around it, we're going to take the line, and then we're going to offset it to give our cell holders some thickness. And then we will extrude, and so you'll see what the cell holder, this is the bottom layer of the cell holders, and then we'll copy that first circle and the outline, and we'll bring them up. So that is what our cell holders look like. We'll throw that into Cura. This is going to be printed on our SnapMaker J1, and it just fits on there, which is great. So if we look at the time, it's going to be 2 hours approximately to print. So we're going to send that to the SnapMaker, start printing, and these cell holders are nice. They print up super easy to design, and work really well. So here are our cell holders. We can just mirror the other side on Cura, and we're using these Samsung 50E cells. So it fits in the bike nice, and we're going to populate all of our cell holders. We've got our pattern, and we're going to start welding with nickel strips. So we're using 0.15 millimeter pure nickel strips, and the aim here is to have at least 5 series connections so that this can flow. It's 30-40 amps. It's a BBS HD, so 30 amps max, but we're going to put a 40 amp BMS on it. So we want it to be able to flow 40 amps nicely and easily. So 5 approximately series strips of pure nickel strip, 0.15. Each one does about 7.5 amps. So 7.5 times 5, 35, 37.5. And we're going to put on our BMS. So first soldering the negative part, and then we're going to put all of our balance leads, trying to run these mindfully so that they're not just all crammed on top of each other. Run them around the pack. And we're going to put a good chunk of padding all around this pack so that none of the wires are going to get pinched. So you can see what these balance leads look like when they're all connected. This battery still fits nicely in this frame with plenty of room, and we'll see how the balance looks after we charged it up. We charged it, and it's pretty much completely perfectly in balance. So now we're going to run our charge lead and our discharge lead. So we're tapping in, we have a common port BMS. We're tapping into that for our charge port and our discharge port, running our positive right from the lead, putting our heat shrink on. We're running XT60 connectors. I know this is moving fast, but we're going to be putting fish paper all around the pack, keep it very well insulated, and then we're going to be using some padding to go around it. So we've done a load test on this battery, and the load test checked out good. Cells did not go out of balance at all, 0.001 volts delta, and now we're using this foam and we're tracing it out, and we're cutting and gluing on the foam all around the battery. And we're going to be using this fiberglass reinforced tape, which is super strong and provides a really nice seal, go all around the battery, and put our little sticker on it and slap it in. This is the stuff that we use, camping mat. You can get it from Dollarama if you're in Canada, or wherever else in the world you may find this kind of stuff, but it's nice and thick, very compressible, good stuff. Works really well. This is another battery just to show you what that looks like. So we just lay it out on the mat, and then we trace it with a Sharpie and then cut it out. Nice and easy, quite effective. And that is the tape that we're using. It's a fiberglass reinforced tape. And that is what it looks like when it's all done. We got nice thick layer all around. You could do blue heat shrink as well if you'd like, but with triangles, those are not quite as satisfying. This is really nice and sealed up. I think it does the job. And let's see how it fits. So we put it in our bag. This is a bag we got off AliExpress from Cam Rider, or Cham Rider. I took off the letter, so it's just Ride that's left. It's got the huge Velcro strap, and then plugged it in, and fits very nice. And this was a look at the bike all done with the battery inside, everything mounted up, and it looks pretty good. Should provide some pretty huge range. 30 amp hour batteries, plenty. And one last look at it in front of the garage door. Overall, I'm really happy with how this thing turned out. I think it's a really nice bike. It's a really good platform to start off with, the Northrock XC00. Really like this display as well. It just looks cool. Also, I believe it auto senses the light, so the front headlight turns on automatically. But anyways, guys, thank you so much for watching. Really hope you enjoyed it. If you want to see more content like this, then definitely like, subscribe, but drop a comment. What do you want to see? Definitely want to make videos for you guys, so I would really love to hear your thoughts. Have a great day, and we'll see you soon.